Hi friends, welcome back to our channel Easy Mathematics. Today we are going to discuss invertible function. We know it is a continuation topic of bijective functions. So when we can say a function is invertible or not. So for example, let f be a function from a to b. F be a function from a to b. So a is domain, b is codomain. When we can say inverse of this function exists, so that is definition of invertible function. We can say inverse of this function exists only if the given function f is bijective. Then when we can say the given function is bijective, in last video we discussed about bijective function in detail. So if f is both 1 1 and on 2, we can say this function f is bijective. So to check inverse function, we want to prove given function is bijective. A function f from a to b is invertible if it is a bijective function. Then how we can define inverse of this given function f? So inverse function f will be a function from b to a. Codomain of the function f become domain of the inverse function. Domain of the function f become codomain of the inverse function. So f is a function from a to b, then f inverse will be a function from b to a. We define inverse functions using pre-images. While defining a function, we have images. Using pre-images, we are defining inverse of that function. A function f is invertible means inverse of that function exists. So a function is said to be invertible if its inverse function exists. So when inverse function will exist, inverse function will exist if it is a bijective function. So a function is invertible means that function is bijective and its inverse function exists. So to verify a function is invertible or not, we want to check whether the function is bijective or not, and after that we want to find inverse of that function. So we know how to check whether the given function is invertible or not. So a function is bijective only if it is both 1 1 and on 2. So to check bijective function, we want to verify the given function is 1 1 and on 2. This implies bijective. Bijective implies invertible. Then we can find inverse of that given function. So this is the procedure that we want to follow to find inverse of a given function. So question from this section we can expect like this. So here f is the given function defined on positive real numbers whose domain is positive real number and codomain is 4 to infinity. given by function is given in this form x square plus 4. Show that f is invertible. So we want to prove the function is invertible, and we want to show that inverse of that function will be like this: f inverse y is equal to square root of y minus 4. So two things we want to prove here. First we want to show function is invertible, then we want to find inverse of that function. To prove a function is invertible, we want to show that the given function f is bijective. To prove bijective, we want to prove the given function is both 1 1 and on 2. So how we can prove 1 1 condition here? So 1 1 means we want to start with f of x1 is equal to f of x2. Then what is f of x1 here? x1 square plus 4, that is equal to f of x2 is x2 square plus 4. So f of x is given, so in x we are replacing with the x1 in f of x1, and to find f of x2 we are replacing x with the x2, that's all. So from both sides what we can cancel? We can cancel 4. Then x1 square is equal to x2 square. Taking square root on both sides, we get plus or minus x1 is equal to plus or minus x2 here, isn't it? But here function is defined on positive real numbers. So here what will come? Minus term will not come. So x1 is equal to x2, plus x1 is equal to plus x2. So from f of x1 is equal to f of x2, we proved x1 is equal to x2. So f is 1 1. So first condition over. Next we want to prove the function is onto. How we can prove a function is onto? We want to start with the codomain. For every y belongs to codomain. Here what is codomain? Codomain is for to infinity, right? Closed for open infinity. If we are able to prove y is equal to f of x, such an x exists in domain, then we can say that the given function is onto. So how we prove y is equal to f of x? F of x is equal to here x square plus 4. We want to find value of x. So y minus 4 is equal to x square. So y minus 4 is equal to x square. So guys, already I uploaded onto function video. If anyone has doubt, please go and check that video. Then y minus 4 is equal to x square. Here we want to find value of x. What will be value of x? Square root of y minus 4. So for every y belongs to codomain, we want to check such an x exists or not in domain. So y value we want to choose it from closed for to infinity. So minimum value of y will be 4 here. So if we are choosing y is equal to 4, what will come? Square root of 4 minus 4, 0. So x is equal to 0. So it is an element in domain R plus. Then x is equal to, suppose y is equal to 6. What will come? Square root of 6 minus 4. That is root 2. Root 2 is a positive real number. So if you choose any y from this codomain, we can find an x satisfying this condition. So what we can write? X is equal to root y minus 4 is an element in R plus. So what we can say? The function f is onto. So here the given function f of x is equal to x square plus 4 satisfies both 1 1 and onto condition. So we can say f is bijective function. So bijective function means inverse exists. And what is procedure for finding inverse? Onto case, same procedure we want to follow to find inverse of the function. start with the y is equal to f of x. Then replace f of x with the given definition. So here it is x square plus 4. From this you find out value of x. So what is value of x? X square is equal to y minus 4. X is equal to square root of y minus 4. Then this x value we call it as f inverse. So here inside square root variable is y, so we are replacing this x with the f inverse of y. So this is the procedure for finding inverse of the given function. So first we proved the given function f is invertible. To prove invertible, we proved both the 1 and onto condition. Then we show that function is bijective. Then we find inverse of the given function. So to find inverse, we are following same procedure as onto function. So we start with y is equal to f of x. From this you find out value of x. You replace that x value with f inverse of y.